Hi guys, I want to talk to you in this lesson a little bit about the idea of a mathematical conjecture and proof. A conjecture is when we think something is true and we say, I think this might be the case. In mathematics, it's not quite good enough to just say, I think this might be the case. In math, we want to offer proof that something is true. Beyond any doubt, we want to know that something is true. We want to prove it. Okay, so I need to start by just making a definition here. We call the line through the middle of a triangle from the vertex down to the midpoint of the other side. We call that the median of a triangle. I've drawn one median for this triangle in blue, but of course there's two other possible medians. One would be from this vertex of the triangle to the midpoint of that side, so about there. Right, there's another possible median, and another median would be from this vertex to the midpoint of that side, so about there. Okay, so those are the three possible medians for the triangle. Now, don't really want these ones. Erase them. It looks like if I draw the median of the triangle, that splits my triangle into two identical pieces. Right? That's my conjecture. I think if I draw the median of a triangle, I'll always create two congruent smaller triangles, just facing opposite directions. Is that true? I made a conjecture, but is it true? It's easy to disprove something in math. All I need to do is think of one counterexample to my statement. So my statement was, if I draw the median of a triangle, I'll always create two identical but flipped smaller triangles. Easy to disprove that. Watch. There's a different shaped triangle. Now, if I draw the median of this triangle from this spot, it'll go to halfway here. But it's really easy to see that those two triangles are not congruent to each other at all. They're not the same shape. All right, I have a different conjecture. This is conjecture number 2. If I draw the median of a triangle, then I'll create two triangles that have the same area. Not necessarily the same shape, but the same area. Now this one I can give proof for. So if I draw any old triangle, okay, here it is. I'm going to draw, really scalene triangle. So I know that if I make the median, here it comes. Now I know that that median divided the triangle into two smaller ones that are not the same shape. My conjecture is they have the same area, and I can prove that that's true. Remember, what's the formula for the area of a triangle? Area is equal to base times height divided by 2. So it would be enough for me if I could say that those two triangles have the same length for the base and the same height. Then their area would have to be the same, because base times height would be the same number, divided by 2 would be the same number. Well, look at these two triangles. They both have a height. Switch to my black marker. No matter which one we're talking about, they both share that same height. We'll call it h, right? And now if the bases are the same length, then for sure the areas are the same size. But because this is a median, it splits that bottom side in two. It meets at the midpoint of that bottom side. So they both have, if we want to call it B, a base the same length. Both triangles have a base that's the same length and the same height. They must have the same area. So that's my proof for that conjecture. Okay. Also, key important point, if you draw a median, it splits the triangle in half and the area in half.